Hello, welcome back. All right, we are we are live. We are live. All right, jumping back into data structures and algorithms in Python. Here we are on page 87, and talking about inheritance in section 2.4 of this chapter, chapter 2. I'm just going to do a quick couple, maybe about 10 pages, and then jump into the Small Business Manager project. Yeah, so should be kind of fun and should be a good chill stream. So yesterday actually we saw a bug introduced when I was demonstrating the task tracker program, and I was able to solve that last night. And I pushed that to GitHub. So go ahead and pull those recent changes if you're using the task tracker, and yeah, you can be able to have the latest bug fix. Anywho, let's go ahead and jump right in. So a second example of the use of inheritance, we develop a hierarchy of classes for iterating numeric progressions. A numeric progression, a second example of the use of inheritance, we develop a hierarchy for classes. A numerical progression is a sequence of numbers where each number depends on one or more previous numbers. For example, an arithmetic progression determines the next number by adding a fixed constant to the previous value, and a geometric progression determines the next number by multiplying the previous values by a fixed constant. Um, so arithmetic progression, right? You go to the prior element and add a fixed constant to it to get to add the next element. And the geometric is a multiplication. In addition, in general, a progression requires a first value and a way of identifying a new value based on one or more previous values. To maximize reusability of code, we develop a hierarchy of classes stemming from a general base class that we name progression. Figure 2.7, right? So progression right here, right? An iterator producing a generic progression. Default iterator produces whole numbers 0, 1, 2, right? Default iterator produces, so by default the iterator produces just whole numbers 0, 1, 2, etc. All right. Technically, the progression class produces the progression of whole numbers 0, 1, 2, etc., etc. However, this class can be designed to serve as the base class for other progressive types, providing as much common functionality as possible, and thereby minimizing the burden on the subclasses. Right, so you have progression, then from progression you have Fibonacci progression, geometric progression, and arithmetic progression, right? Our implementation of the basic progression class is provided by the code fragment in 2.8. Code fragment 2.8, yeah, this is 2.8, right? Okay. The constructor for this class accepts a start value for the progression 0 by default and initializes a data member self._current to the value, right? So right here, when we initialize an instance of this progression class or an object, you provide a start value, which is 0 by default, and then the instance variable is saved to that value. The progression class implements the conventions of the Python iterator, see section 2.3.4, namely the special dunder next and dunder iter methods. If a user of the class creates a progression as sequence is the variable where just equals progression, each call to the next sequence will return a subsequent element of that progression sequence. It would also be possible to use a for loop syntax for value in sequence, although we note that our default progression is defined as an infinite sequence. To better separate, yeah, because if you were to loop over every value in the sequence generated through just a default progression, it goes on infinitely, so you would be looping through infinite values, so you would actually never end, which is infinite loop. So to better separate the mechanics of the iterator convention from the core logic of advancing the progression, our framework relies on a non-public method named _advance to update the value of self._current field, right? So we have this def_advance where it takes in self and the type of sentence says updates self._current to the new value. This should be overridden by a subclass to customize progression. By convention, if current is set to none, um, this designates the end of a finite progression. Okay. So, yeah, in the default implementation, an underscore advance adds 1 to the current value. Right, so yeah, advance just takes current and adds one increments up by 1, right? Uh, but our intent is that the subclasses will override the underscore advance to provide a different rule for computing the next entry. For convenience, the progression class also provides a utility method named print progression that displays the next n values of the progression. So right, you have def print progression. So um, print print space dot join for next cell for j in range of n. Interesting. All right. In the default implementation, all right, so yeah, arithmetic progression class. Our first example of a specialized progression is an arithmetic progression. While the default progression increases its value by 1 in each step, an arithmetic progression adds a fixed constant to one term of the progression of to the next to produce the next. For example, using the increment of 4 for an arithmetic progression that starts at 0 results in 0, 4, 8, 12, right? Code fragment 2.9 represents our implementation of the arithmetic progression class, which relies on progression class as its base class. The constructor for this new class accepts both an increment value and a starting value as parameters, although default values for each are provided. By our convention, arithmetic progression 4 produces a sequence of 0, 4, 8, 12, and arithmetic progression 4, comma 1 produces a sequence of 1, 4, 5, 9. Okay, so you give it an increment as start and then a start position. Okay. The body of the arithmetic progression constructor calls the superconstructor to initialize the underscore current data member to the desired start value, right? So when we initialize, we super the init start from progression here. So underscore current. Calls the superconstructor to the underscore current data member to the desired start value. Then it directly establishes a new underscore self increment member of the arithmetic progression. The only remaining detail in our implementation is to override the underscore advance method to add the increment to the current value. So in this one, they just take the current method, add the increment. Right. Okay, interesting. Our second example of a specialized progression is a geometric expression in which each value is produced by multiplying the preceding value by a fixed constant known as the base of the geometric progression. The starting point of a geometric progression is traditionally 1 rather than 0 because multiplying by 0 by any factor results in 0, right? Okay, exactly. So you have to start by 1 or any other factor non-zero. As an example, a geometric progression with a base 2 proceeds as 1, 2, 4, 8, 16. So you multiply the previous by 2. 1 by 2 produces 2, 2 by 2, 1 by 2 produces 2, 2 by 2 produces 4, 4 by 2 produces 8, 8 by 2 produces 16. Code fragment 2.10 represents our implementation of the geometric progression class. The constructor uses 2 as a default base and 1 as a default starting value, but either of those can be varied using optional parameters. So class geometric progression, iterator producing a geometric progression. So we initialize, we super the start value from before, and so we will gain access to the self dot underscore current, and now we assign base to its own instance variable or data member, and then we override advance with, we take current and multiply equal to bounds, right, to the base. As our final example, a Fibonacci progression class. As our final example, we demonstrate how to use our progression framework to produce a Fibonacci progression. We originally discussed the hello, if you're watching, I appreciate you joining. We originally discussed the Fibonacci series on page 41 in the context of generators. Each value of a Fibonacci series is the sum of the 2 most recent values. To begin the series, the first 2 values are conventionally 0 and 1. Oka Nips, supporting you. I'm also trying to learn Python. Awesome, thanks. That's really awesome. I appreciate you leaving the comment. Yeah, exactly what I'm doing. I have some books here, much Python machine learning, Fluent Python, and I've already read the Python crash course. And I'm going through the try it yourself problems, posting some videos on my channel for these. So feel free to follow along if that's something that interests you, Oka Nips. Appreciate you coming and leaving a comment. Really awesome, man. Yeah, so we're in data structures and algorithms in Python right now, trying to learn about DSA. I figure that's kind of like the next element in my learning I should try to dive into. So we're on page almost 91 here. So as our final Fibonacci progression, so the Fibonacci is the sum of the previous 2 values. So we start with 0 and 1, well the sum is just 1. So we then have 1 and 1, sum is 2, 2 and 1, sum is 3, 2 and 3, sum is 5, 3 and 5, sum is 8, right? More generally, such a series can be generated from any 2 starting values. For example, starting with 4 and 6 will result in 10, 6 plus 10 is 16, 26 to 16 is 42. So the class Fibonacci progression takes in a base class of progression, right? So when we initialize, we have a value of first, which has a default of 0, and second, which has a default of 1. So this is the first value in our sequence and the second value in our sequence. We super the first value from the progression class, right? And because this doesn't have a start, how do you stay so disciplined to learn something? I like doing it. Well, honestly, this the stream really helps. I have made some acquaintances on here that pop in regularly, and that through just wanting to provide some sort of entertainment or other value to people that are learning as well also helps motivate. And also, I just don't have a lot of other hobbies, which also helps. Is I kind of this is my kind of my hobby, so. Um, all right, so we super first from the initialized, but progression doesn't have a first, right? So let's just we use our progression framework to define a new Fibonacci progression class shown as code fragment 2.11. This class is marked differently from those for the arithmetic and geometric progressions because we cannot determine the next value of the Fibonacci series solely from the current one. Right? We must maintain knowledge of the 2 most recent values. The base progression class already provides storage of the most recent values as the underscore current data member. Our Fibonacci progression class introduces a new member named underscore previous or prev to store the value that preceded the current one. So I get that you can't, I don't think this works though. This is a typo. Am I wrong though? This, so the progression class doesn't have a start or a first. It has a start equals, right? And that is saved to current. So we can't super a first right? It would have to be start. Interesting. Because they're trying to access self._current, and that is not assigned to first in the progression class. That is assigned to start, the variable quote start. So I think that's a bug. It's a typo here. I mean, they're trying to, obviously be explicit that with Fibonacci's you have to use the first and second number, and then continually update those as you move on the sequence. But, yeah. So we super the start progression as first. So first equals 0. And then we establish a previous, which is just second minus first. Okay. So then to advance, we take the previous and the current, we update them by taking the current value we're on and then the previous plus self_current. Okay, this is interesting. Okay, so we must maintain knowledge of the two most recent values. The base progression class already provides store's most recent value as the _current data member. Our Fibonacci progression class introduces a new member named _prev to store the value that preceded the current one. With both the previous values stored and the implementation of _advance is relatively straightforward. We use simultaneous assignment, similar to that on page 45. However, the question arises how to initialize the previous value in the constructor. The desired first and second values are provided as parameters to the constructor. The first should be stored as _current so that it becomes the first one that is reported. Looking ahead, once the first value is reported, we will do an assignment to set the new current value, which will be the second value reported, equal to the first value plus the quote unquote previous. So looking ahead, once the first value is reported, so if the first value is 0, we report that as current. We will do the assignment to set the new current value, which will be the second value. If that's 1, it'll be the previous plus 1. Or 1 plus the previous, which would be 0. By initializing that previous value to first minus second, the initial advancement will set the current value to first plus second minus first equals the second as desired. Interesting. They could have just done this by indexing, but they're trying to generate the list by providing two start values, I guess. So testing our progressions. To complete the presentation, our presentation code fragment 2.12 provides a unit test for all of our progression classes, and code fragment 2.13 shows the output of that test. If name is equal to, if under name is equal to quote under main, print default progressions, print progression 10, progression.print _progression 10. So these are just tests, okay, and then they show the cases. Okay, abstract base class. When defining a group of classes as part of an inheritance hierarchy, one technique for avoiding repetition of code is to design a base class with common functionality that can be inherited by other classes that need it. As an example, the hierarchy from section 2.4.2 includes a progression class which serves as a base class for all distinct subclasses: arithmetic progression, geometric progression, and the Fibonacci progression. Although it is possible to create an instance of the progression-based class, there is a little value in doing so because its behavior is simply a special case of an arithmetic progression with increment of 1. Although it's possible to create an instance of the progression-based class. here simply to make it an arithmetic. Oh, yeah, so the base class is just an arithmetic class with an increment of 1, right? So the real purpose of the progression class was to centralize the implementations of behaviors that other progressions needed, thereby streamlining the code. So the whole point of creating progression class itself wasn't to actually have the progression class ever really be called, but rather, um, to build these branch classes off of it from the base class. Um, so kind of creating that framework. In classic object-oriented terminology, we say a class is an abstract base class if its only purpose is to serve as a base class through inheritance. In classic object, we say a class is an abstract base class if its only purpose is to serve as a base class through inheritance. More formally, an abstract base class is one that cannot be directly instantiated, while a concrete class is one that can be instantiated. So in our case of our project we're working on, the items class is it's a base class, but it's not a abstract base class because it does get called to create new items. So more formally, an abstract base class is one that cannot be as concrete. By definition, our progression class is technically concrete, although we essentially designed it as an abstract base class. In statically typed languages such as Java and C++, an abstract class serves as a formal type that may guarantee one or more abstract methods. In statically typed languages such as Java, an abstract base class serves as a formal type that can guarantee one or more abstract methods. This provides support for polymorphism, as a variable may have an abstract base class as its declared type, even though it refers to an instance of a concrete subclass. Because there are no declared types in Python. Hello, Beanbag. Appreciate you coming in and giving a comment. Feel free to follow along to how do you think like a programmer? I don't. I'm not really like. I don't really have a ton of advice, I guess, but I definitely have noticed my thinking has started to shift into thinking from like the user's point of view more often. Like when I'm writing code, I often think, well, if I was going to attempt to use this code, what kind of bugs would I encounter, and how could I solve those right now rather than later on? And that mindset, I've definitely noticed I've started to develop. Just the general problem solving mind, it's pretty stereotypical. The problem solving skills definitely increase. You think about there's multiple answers to solutions, right? For example, if you want to find if you're given a number and you want to find out if it's even or odd, well, you could just use the modulo operator, or you could loop that number down. Like you could loop that number. You could subtract 2 from that number down all the way until it either reaches 1 or 0, and then depending on that, if it's 1 or 0, depending on if it's odd or even. And there's, or you could use binary to the bin and the binary and operator to combine or add like the two binary integers together to produce a single binary number that would either be odd or even depending on the 0 or 1 in the last place. It's there's just a lot of different. I kind of went on a ramble there, but it's just there's a lot of different ways to think about things, and if you convince yourself there's only one answer, well, oftentimes you're wrong, and you can. There's multiple paths, so you don't need to be searching for one answer. You can search for 5 or 10 answers. Depends. Right, like visually thinking. Visually thinking, I use this stream to, study. I read out loud these books to the stream as if I'm reading to someone or as to the people out there. And, some people are in here, some people aren't. Even if there aren't people in here, I read out loud, and it helps to I talk through the things that they're talking about. Um, do you code with the end in mind? In other words, for example, have a clear picture of what should be built by the time you're finished with your project. Yeah, I kind of do actually. Like I know I have like an end goal of like where I want to reach and what features I want to do. And obviously, some creative stuff pops up, and I want to add things when I think of them. But for the most part, what I've created and thought of, I had pre already determined all of the features in my mind before I went into them, which definitely helped to be productive. Okay. Uh, this provides support for polymorphism. Okay. Because there are no declared types in Python, this kind of polymorphism can be accomplished without the need for unifying abstract base classes. For this reason, there is not a strong tradition of defining abstract base classes in Python, although Python's ABC module provides support for defining a formal abstract base class. Our reason for focusing on abstract base classes in our study of data structures is that Python's collections module provides several abstract base classes that assist when defining custom data structures that share a common interface with some of the Python's built-in data structures. These rely on an object-oriented software design pattern known as the template method pattern. The template method pattern is when an abstract base class provides concrete behaviors that rely upon calls to other abstract behaviors. The template method pattern is when an abstract base class or a class that isn't supposed to be instantiated objects but just used as a building block provides concrete behaviors that rely upon calls to other abstract behaviors. See, this is pretty like abstract itself. They need to be. This definition sucks, like really bad. Like, what does this mean? Like, you can't expect anyone with like, to, come on, like, in that way, as soon as a subclass provides definitions for, okay, so in that way, as soon as a subclass provides definitions for the missing abstract behaviors, the inherited concrete behaviors are well defined. Okay, this paragraph really sucks. Sometimes this writer is kind of annoying. The template method pattern is a behavioral design pattern used in object-oriented programming. It defines the skeleton of an algorithm in an abstract class, allowing subclasses to provide specific elements, specific implementations for certain steps of the algorithm. Here's a breakdown of how it works. Abstract base class contains the template method, which defines the overall algorithm structure, implements concrete behaviors methods that are shared across subclasses, declares abstract methods that subclasses must implement. So concrete subclasses, extend the abstract base class, provide specific implementations for the abstract methods, tailoring the behavior to particular cases. By using this pattern, the base class ensures that by using this pattern, the base class ensures that the algorithm structure is consistent across all subclasses while delegating the specific behaviors to the subclasses. Okay, so what does this look like? So from ABC, import ABC abstract method. So we have a data processor class, which processes data, load data. So there is no initialization method within this class. So this is the base class, right? So load data, clean data, analyze data, save results. Okay, so these are calls that can be made from process data. So then you can use the decorator abstract method right here from ABC to access the load data. Oh no, you're defining load data. And you take in self and you pass. Okay, and you do that for clean. And save results. Results save the database concrete method. So concrete. Oh, okay, I get what this is. So what's so Beanbag says, all right, because then you know how long have you been programming? I started programming at the beginning of June, end of May, so just 5 6 months now. Yeah, I don't read these books. I just do the coding samples. I can't understand them. Yeah, they're pretty. They have a lot of jargon, but I find that the jargon, once you are familiar with the jargon and the technical wording, um, and get those definitions as to more like more fundamental and more consistent in your mind, the books really do explain a lot. Reading, I kind of underestimated the power of books. Yeah. So what this? Okay. So I figured this out. So you have these abstract methods for this ABC class data processor, right? And it has these um, this process data templates with these accessible points. So you can do process data dot load data, right? Um, Now, what you can do is you pass use these functions abstract method, these load data, clean data, analyze data, and then just pass them with this abstract method decorator because this is just a template. And then you can create a concrete class and then override the pre-existing load data um, like uh, like the so you can just you can just override. So code reuse, right? Common behaviors are implemented in the base class. Subclasses provide specific details for abstract methods how without altering the template structure. Encapsulation of the algorithm, keeping the algorithm's high level structure intact while delegating specific details, right? So and then we could say like, oh, PNG data processor, right? Loading PNG data. You could remake this class for any kind of data file or data processing processor. All right, what did you take in college? Which degree? I have a degree in human biology and a minor in chemistry, and so I have a specialty in like the chemistry side of human biology. And I work as a formulation chemist for a biotech company. I make biological controls and stuff like that in the lab. Okay, so let's go ahead and continue here. This makes more sense. As tangible, as a tangible example, the collections.sequence abstract-based class defines behaviors common to Python's list, str, and tuple classes as sequences that support element access via an integer index. More so, the collections.sequence class provides concrete implementations of methods, count, index, and dunder contains that can be inherited by any class that provides concrete implementations of both dunder length and dunder get item. For the purpose of illustration, we provide a sample implementation of such a sequence abstract base class in code fragment 2.14. Right, so let's look at this one. So from ABC import ABC meta abstract method decorator. Okay. Uh, which degree? How long have you been coding for? Beanbag. And feel free to follow the channel so we can communicate next time you stop in. What brings you to learn programming? How often? How do you people code anything in their mind? I don't get it. I'm a year and a half ish in, and it's still like I don't get people just code anything like they have in mind. Well, it kind of it definitely helps to have real world problems that you want to solve. So I I have like the project I'm working on after I get done studying this book is just a small business manager kind of generating tax documents, loading inventories, tracking sales and stuff like that. And I think it would be really valuable for me, a small business owner, for the small business that I own, and then on the side, and then for others as well. So just takes whatever kind of it does take creativity. So programming is kind of an art form, like it is in some schools under the arts degrees because it is a pretty creative field. Uh, So yeah, so we have class sequence meta class equals ABC meta class. Our own version of collections of sequence abstract base class. So abstract method. So you just have length returns the length of the sequence. Get item contains for j in range of the length. If self j is equal to value, return true as false. Index count. Yeah, okay. Is that why you're doing programming? Yeah, it's like you can make anything out of nothing. Yeah, exactly. It's you can whatever idea you have, you can make a computer do it. It's pretty interesting, and it's very intriguing to mess around with, and it's very rewarding to also learn. You when you finally like learn and are learning and feel like you are getting it, it feels very rewarding. Okay, this implementation relies on two advanced Python techniques. The first is we declare the ABC meta class of the ABC module as a meta class of our sequence class. A meta class is different from a superclass. That is, it provides a template for the class definition itself. Specifically, the ABC meta declaration assures that the constructor for the class raises an error. A metaclass is a class of a class, meaning it defines how a class behaves, not just the objects created from it. It acts as a template for class definitions, influencing how the class itself is constructed rather than the instances of the class. In Python, metaclasses are typically used to enforce rules on class definitions, automatically register classes, or customize behaviors at the class level. Key difference between metaclasses and superclasses. A metaclass operates at the class level, dictating how classes themselves are created or validated. A superclass operates at the instance level, providing methods and attributes that instances of the subclasses inherit. So ABC meta and abstract base class. An ABC meta is a meta class provided by Python's ABC module. It ensures that a class cannot be instantiated until all its abstract methods have been implemented in a concrete subclass. Okay, so by declaring it a meta class, you just say that okay, this class is a abstract base class. It cannot be, you know, reused or have a subclass called on it unless it has all of these methods filled out for it, right? So here's an example. Okay, let's continue reading first. So, um, ABC meta class ensures that class cannot be instantiated unless all of its abstract methods have been implemented in the concrete class. Yep, subclass. When a class declares ABC meta as its meta class, it contains abstract methods decorated with abstract method. Any attempt to instantiate the class without fully implementing all the abstract methods will raise an error. Exactly. So you have to have put in these abstract methods um, in order to call this subclasses of the abstract shape. Gotcha. It ensures class addition. Okay, cool. The second advanced technique is the use of the abstract method decorator. Immediately before the dunder length and dunder get item methods are declared, that declares these two particular methods to be abstract, meaning that we do not provide an implementation within our sequence base class, but that we expect any concrete subclasses to support these two methods. Python enforces this implementation by disallowing the instantiation for any subclasses that do not override the abstract methods with concrete implementation. So if I were to create a subclass using this sequence as my base class or my abstract base class, because it is meta tagged as a meta class, I have to override these abstract method decorator methods in order to use it, or I will be thrown an error. The rest of the sequence class defines possible tangible implementations for other behaviors under the assumption that the abstract dunderLength and dunderGetItem methods will exist in a concrete subclass. If you carefully examine the source code, the implementations of methods dunder contains, index, and count do not rely on any of the assumptions about the self instances other than that syntax length self and self j are supported by special methods dunderLength and dunderGetItem respectively. Support for iteration automatic as well as described in section 2.3.4. So what I believe that was referring to was these items here, right? So the contains refers to the instance itself. But this would be more along the lines of the class, I'm assuming. Carefully examine the source code. The implementations that dunder contains index and counts do not rely. So index do not rely on any assumptions about self instances other than that syntax, the length of self, and the self index j are supported. I want more info on this. So the sequence class in Python, typically from the collections ABC module, is an example of the abstract base class that defines construct. The dunderLength method returns the number of items in a sequence, and the dunderGetItem method supporting indexing sequence index are the only required methods for a concrete subclass of sequence. Once implemented, all other sequence operations are built on top of them. Concrete methods contains, index, and count, right? Contains determines if an element exists. I don't know why it sometimes does the balloons. It's funny. I think if I do a thumbs up, it'll do thumbs ups. Do a thumbs up thing. No? Okay. Alright, where were we? So the sequence class provides concrete implementations for the other methods, right? These don't have the decorator. So the dunder contains determines if the element exists in the sequence. So contains for j in the range of the length of the self. So take the length and then range. So for item in the 0 to the length of the sequence if self index j, if the sequence at that index point is equal to the value provided that the user provide when the contains, then return that value is in the sequence, right? If the item at that index is equal to the value provided, then return true, else return false. It means it's contained in the sequence, exactly. So returns cool. Definitely using Jipity to kind of go over some of these paragraphs definitely helps to really get this in. So let's see here. In the remainder of this book, we omit the formality of using the ABC module. If we need an abstract base class, we simply document the expectation that subclasses provide assumed functionality without technical declaration of the methods as abstract. But we will make use of the wonderful abstract base classes that are defined within the collections module, such as sequence, to use such a class, we need only rely on standard inheritance techniques. Okay, so they're not going to, for the remainder of the book, they're not going to use ABC module, but they will use sequence from collections. For example, our range class, right, from code fragment 2.6, where's 2.6? 2.0, way up here. 2.6, figure 2.6, figure 2.5, fragment 2.6, range class right here. So when we initialize, we give a start stop, which is default none, and step, which is default 1. If the step is equal to none, raise value, we can't have step equal to 0. If stop is none, stop is equal to 0, start, stop, right? So, okay, exactly. That's just reiteration of the length function. We're almost ready to kind of pause here on this. We'll get to the end of this page and stop right here, 2.5. All right. For example, our range class from code fragment 2.6 of section 2.3.5 is an example of a class that supports the dunder length and dunder get item methods, but that class does not support methods count or index. Had we originally declared with sequence as a superclass, then it would also inherit the count and index methods. The syntax for such a declaration would begin with as class range collection sequence. Okay, so you can use sequence from collections module as your base class to also inherit the count and index methods without having to put them up yourself. So okay, interesting. Finally, we emphasize that if a subclass provides its own implementation of an inherited behavior from a base class, so if it overrides a base class behavior, the new definitions overrides the inherited ones. Right, exactly. This technique can be used when we have the ability to provide a more efficient implementation behavior than is achieved in the generic approach. As an example, the general implementation of dunder contains for a sequence is based on a loop used to search for the desired value. Exactly. We just looked over that. For our range class, there is an opportunity for a more efficient determination of containment. For example, if it is evident that the expression 100,000 in range 0 to 2 million with a skip of 100 should evaluate to true even without examining the individual elements of the range, because the range starts with 0, has an increment of 100 and goes to 2 million. It must include 100,000, right? This is just kind of simple logic in a sense. Well, I don't even really need to compute this, this computer problem, this line of code, because, well, just because we're starting at 0 and we're going up by 100 every time, well, we know that eventually we're going to hit this number, right? Just logically speaking. So we can infer then that will return true. It must, as is a multiple of 100, and that is between the start and stop values. Explores exercise C 2.27 explores the goal of providing an implementation for range dunder contains that avoids the use of a time-consuming loop, right? So you could say, like, if you could use some sort of factor implementation here, right? Okay, cool. So we will stop there for the reading for today. That was very insightful, very good reading. Learned a lot about subclasses, ABC module, collection sequence, just general setting up dunder contains, dunder length, dunder get item, all that kind of stuff. Really interesting. Anywho, should we, should focus here onto the project? I got the hiccups, I'm sorry. How much of the chapter do we have left? So we have 1, 2, 3, 4, 5, 6, 7, 7 pages. So that'll be perfect for tomorrow then. And then we can jump right into the reinforcements to warm up and then once we get through, we'll warm up with the reinforcements, and then we'll move on to chapter 3 after that. Cool. Go back up here. Spaces. All right, so let me open up my project. So I want to actually open up the Task Tracker app really quick and run it here and test for a bug real fast. So this was the Task Tracker app we made last time. Not last time, but last month. This is currently on my GitHub, link in the description of the stream right now. If you're watching, I appreciate you joining. Feel free to follow the channel if you're interested in learning Python alongside me. All right. So I have a task here that is supposed to be expired today, right? So this should expire. I want to see if this still expires based on the bug fix we did yesterday. So if I run this and we load in, ooh. Oh boy. Oh no, this isn't expired. This is due today. Okay, phew. Whew. Oh boy, phew. Okay, so let me quit. I thought we had another bug. Oh my gosh. So if we view, we can see this is due final project date due, days to complete 1. Now see, this added a date. So if I main menu and I exit, yeah. Interesting. Okay. So we have another bug, unfortunately, guys. So when items are being updated for expired, they are being overridden. The expired detection is being overridden by it's being overridden somewhere. So let me see here. We have so update task takes days to complete, sets it news day completes over sets it to days complete. Then using days complete we separate and set date due, right? And the set date due was what was changed. So then when we go to update days to complete, we run current date today for tasks, the task days to complete, right? This is equal to the task due date that was read task due date minus the current date to get the days left, right, to complete. Now the days left to complete and is converted back into a day element from just the days. So then when we check expired, we've got more balloons. I don't know what the balloons mean. What do the balloons mean? Check expired. So when we check expired for tasks in the task list copy, if the task's days to complete is less than 0, we remove it. We append it to the global expired task list. So that's just display. So then when I run main here, I load task file and I update days to complete. And I say for task and task. I hate this formatting. This is so annoying. So for task in my task days to complete, or my task list, right? I want to set the priority using the task I'm using and using the days to complete. I run check expired, and then I run display expired, and then I run system. So then when I run system, I'm here. So if I so this if I run this, I'm in here, right? Yes. No expired tasks. I quit. And I exit. That updates to 27. So somewhere in my code, my date due is being updated. Date due plus days complete equals date due. Where is that happening? So it's gotta happen when I maybe filter sort. It's not save. It's gotta be. Is it gotta be happen when I either load? Okay, here or date due. So I'm setting date due, right? When I instantiate, I'm setting the date due using the set date due with the days to complete. So I need to put a catch here, I think, to combat this bug. So what kind of catch do I need to put here? So if so right now, because right now it's taking my days to complete and then overriding oh no, it's with set date due. Task.set date due. So set date due. Where's that at? Here. Okay, so we take the date due as the days to complete, which would be in this case 1. In this case, it would be 1, so the days to complete would be 1. And then what it's doing is it's taking the 1 plus the date today, which would be the 26th, and then setting that to date due. Which is, we don't want that to happen when we load the program. But when we create elements, we're going to take it on the current day. So how would we want to solve this problem then? When we create an element or create an object, the date is being set, the due date is being set like this, right? It's taking the date that's today So it have to be if what I need to use a parameter. So if I would have to be the previous date. We're getting there. We're almost there here. So we're in the right area. We're in the right ballpark. So rather than using the current date today, because it's saying, okay, if I load the task day, the 26th, it's going to take that day to complete, which is 1, and then it's going to create the due date and make it tomorrow, right? So we don't want that to happen. We don't want to use the date today. We need to use self dot so if I'm wanting to set the date due, you would have to do days to complete plus the date the object was created, right? So this would be self dot date created, right? This is if an object is not there. This is if it's a brand new object. Set date due on the date created plus days to complete. Now that's going to cause a problem though, because if I set the date due when I load objects in, if I use the date created, right, it's going to set the date due based on the date created now for previous loaded objects. So it's going to update date due see, this is where I think I went wrong with keeping the function happening in the class, because now I'm getting bugs where I needed to keep things separate. I'm not sure how to solve this. I will get it eventually, but it's going to take me some time. So I'm sorry if this is boring, but this is definitely a part of the process of solving these problems. So if I am to create a new object, right, we use the date created plus the days to complete given would set a date due, right? Um, if so, and then if we have update task, would be new days to complete with set date due. I not sure, not sure. So when we are reading new objects, reading already existing objects, it's going to run this line of code to set the date due. And what it's going to do is it's going to take this date created, and then it's going to add onto it the days to complete that the object is provided. Days to complete. Yeah. And so it's going to then make this due technically on the 19th, and it will be expired then. And we don't want that. Right? If I run this now, that's exactly what's going to happen. As I say yes, it's going to show it's expired, but it's going to show it expired the 19th. So when we quit, clear. So we might need to, what we might need to do here is do date do is equal to none, right? We might make it default parameter, right? And then set date do, say if date do, right? We want to if the user provides a date do, no, I don't think I don't think that would really do anything actually. Right now this is setting the date underscore do based on the days to complete and the date created. Then when we load the tasks, we're loading a date created from row 2. So then how can we determine if the task is now expired? This needs to be updated. Days complete is current day. Due date minus current day is equal to update days to complete. So where else am I running this function? Right here. So I'm running it here after I load. So this is going to set my date due to 19 though from the jump right here. So right, it's going to set it to 19 right here when I load. So that I load, I'm reinitializing and then set date due. Yeah, I need to have the user be able to provide a date due, which would be row 3. 0, 1, 2, 3. Right, so if I have row date due is row 3, and then I have the user be able to give it in the class creation, and then date due is equal to none, right? So now it's defaulted to none. So now when I create it, if the user provides, so if date due, if the user provides one, we want to set self.date due is equal to date due, right? Else else this, right? So now if and when the tasks are loaded and read, right, it will read that the task already has a date due associated with it. It'll say, oh, this task has a date due on 11/26. Okay, knowing that, when I go to create it, this object right here, right, when I go to create it, um, I'll do all of this, right, initialize it, boom, 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 and then I'll get to right here. Oh, it already has a date due, so I'm going to set self.dateDue to that. Else, oh, if it doesn't, I'm going to set the self.dateDue equal to set date due, um, which should be based on the days to complete. So now I believe that that fixes our bug. I could be naive, but so now if I go like this and I press 1, okay, here we go. Okay, so now I have some date time things going on. So now I need to, so in update days to complete, right here, we have, this is a string, task.dateDue. So how to convert a string into a date time date. To convert a string into a date time date object, you can use a trip time method. Okay. So I need to actually, I think, kind of copy my implementation of what I did above here. So right here, I try to do this. If date created, try to okay, so this is exactly what we want to do. Take right here. So try if date due, right? We want to take the try and put it right here. Inside the try, we want to put this guy. But then we want to copy this, put that there, put this here, copy this, put that there, boom, and then except, right, for a value error, self.date due is equal to date today. Okay, so now that converts this into a datetime object by stripping off the time for the date due and in this format and keeping the date. So now if we go back to here, clear, this is what was throwing the error right here. This was in a string and it was trying to take a string and subtract it from a datetime element. Now I have a datetime element subtracting from a datetime element, I believe. So if I run, right, we have our task that should not be expired. It should be updated. Boom, no expired task, perfect. Quit. View. Final project is due today, 11/26, perfect. So now if I go main menu and then say exit, perfect. That stays the same and that was updated appropriately. Okay, so now let's say this was due the 25th. And this has 1 day to complete, right? Or this is due the 25th and we're opening the 26th. It'll be 7 days to complete from the 18th. Or 6. Whatever. So now if I open this up, this should show expired. Perfect. This expired 11/25. And then if I quit and exit, it's removed. Perfect. So then if I clear, let me bring that guy back. Let me change this back to being in date. Perfect. And then let's say right, and then let's run this program. Let's try to add a new task, make sure that didn't break. Perfect. So this will show no expired tasks, right? Because this is due today and it'll expire tomorrow. And then so if we press quit, quit. So now if we add a new task, right? New task test. 5 days. We view. This task is due in 5 days. Perfect. So if I go main menu, edit task, remove task, remove task. There we go. Now let's add it back. Task test, and let's make it 1 day to complete. View. This is due tomorrow, the 27th. Perfect. So now if I go main menu and I exit, that was updated and that's added. Perfect. So that is working. Awoken Nep says, how old are you if you don't mind me asking? I am 25. Almost going on 26 here. So getting old. Yeah, getting old. Okay, sweet. So we fixed the bug. So what we did, let's go over the changes that we made, right? So what was happening, for those that might not were following, what was happening before was when we were reading the file, right, with our class method, unfortunately, I chose the option when I was making this to store all of my data within the class rather than within the script itself. So I'm having some clashing methods here, and because of that, it's getting a little bit tricky. And so I'll know that for my next project. But with debugging this, when we loaded these files, right, initially I was just using a task title, a date created, and a days to complete. I did not include this date due here. This is new, right? This right here. So I added this in. So what this is essentially doing is when it reads pre-existing tasks that is found within this file, task.csv, it's going to pull specifically this pre-existing value of 2024-11-26 in a string format. Now it's going to pull that and save it to this variable date due. Exactly, right? And then we're going to use that date due variable and create the instance of this class. So when we create the instance, what's happening is now when we added this block right here. So if the user provided, we added also we made the date due parameter up here. We added it in and made it default to none. So the user can provide one and override it, or doesn't have to. So the date due. So if the user provides a date due, we're going to try and, just for some, safety, we're going to use a try block here. We're going to try and, save the instance variable self.dateDue as this date due that the user entered in the string, right? But it's going to check this using this function here. Now this might seem tricky, but what all this is doing is it's using the datetime module. It's using the method strip time to remove the time associated with this creation of this element. It's going to check that it's in this format, and then it's only going to return the date value. That I only want the date, right, associated with it. So, and then, um, and so then, but if it's not in this format, it's going to throw me a value error, and then it's just going to default by setting it to today as like an override safety. So it can still work. It'll just have to be edited manually by the user. Um, so the um, so in this chunk right here, so if else, like if the user does not provide a date due specifically, like we are creating a new object, right? When we're creating new objects, rather than reading pre-existing ones on a file, when we're creating it, all we need is the name and the days to complete, because then it will automatically compute days to complete plus the current day created equals my due date. And so that's exactly what's happening within this function of set due date, right? Set due date right here is taking the days to complete given, it's taking and then adding it to the date created to get a future due date, and then returning self.due date. And and then we're assigning it there. So that's exactly what's happening. So now we are appropriately handling um, when the when pre-existing tasks are being detected, they are not just being having their due dates overridden for the current date that's happening in this else chunk here, right? We needed to add this catch to say, oh, the user added it has a pre-existing due date on this task because it's an already known task in the file. So we need to save that rather than just using an overriding it with this function here based on the current date or the date created that the task was created as if it was from fresh. So this is the solution to that bug, and we were successful. So let's go ahead and just test it out one more time here. I'll show you the file. I run this. I will, I'll say no here just to go back. I'll make this due the 25th so you can see that this was due yesterday. So if I go ahead and open this up, right, run the program. As you can see, we get prompted with these are the tasks that expired while you were away. Expired task, final project was due on the 25th, and we can press Q to exit this view. And then we can view the tasks. These are the current tasks we have in there with that test task. Let's go ahead and main menu. Let's go ahead and edit the task list, remove a task. Let's remove that one task so we can add it back as test task. And then days to complete, we'll say 3. And then we can view, and as you can see, 3 days from now, the 29th, test task is due. And if we go main menu, exit, and then we go ahead and see that that's populated right there. If we run this program, no expired tasks, and view, there's our task, still due on the 29th, 3 days from now. So everything is staying consistent for different days in the future. So I think that concludes our bugs that we'll face for this specific format. Now, I did notice that there was some improper clearing of the terminal before like a little display prompt was like right there. You can see invalid input is being flashed super fast rather than so it's being the loop is being continued in the wrong order there. So I will need to debug some of those formatting flow methods, but just flow through the module. But yeah, so let's go ahead and main menu here, exit, and then let's git add task class. And let's get commit with the message, fixed bug, fixed date due bug for so we fixed the date due bug for loading pre-existing tasks. All right, and then let's git push this. So now, if you guys want to pull the latest changes for the task tracker, you can see those changes live. And yeah, so that's actually going to do it for me for this stream. It was about an hour and a half. I'm going to work on getting some more of the try it yourself problems uploaded from Python Crash Course, because I know there's a lot of beginners like myself, even more freshy beginners than myself, um, hopping onto the channel. And so these Python Crash Course try it yourself problems are so basic that they really help you get. They might seem so basic that they're too easy, but being too easy is what really helps you solidify these easy concepts in computer science and programming. So you never can go wrong with too much practice and help, even if the problem is too easy. So yeah, just simple loop through this, print this, do this, solve this, just various small beginner problems that can help you solidify concepts. But yeah, so that was this program, and so we didn't get a chance to shift over to the small business manager today, that project, but I wanted to fix this bug today that we noticed last night. So thank you so much for watching, you guys. I'll see you guys tomorrow. Peace out.